Thermal physics, question 26. A microwave oven uses electromagnetic waves to transfer energy to a certain substances, such as water. The frequency of an electromagnetic wave generated in a microwave oven is 2.45 gigahertz. Calculate the wavelength. So if we need the wavelength, we have the formula V equals F lambda. So the lambda will be equals to the ratio of speed and the frequency. Speed of all electromagnetic wave, that is 3 into 10 to the power 8. And this will be 2.45. Giga means 10 power 9 hertz. So when we divide, we will get the ratio which is 0.0122 meters. That's the wavelength. The next is the teacher determine the efficiency of a microwave oven. She places a glass beaker which contains 225 grams of a water in a microwave oven and input is 550 watts. The microwave oven is switched on for 120 seconds and it causes an increase in temperature. The specific heat capacity is given. So we need the efficiency of the microwave. So the input of the microwave oven, it is giving 550 watts for how many minutes? 120 seconds. So the total energy which is provided, that is power multiplied by time. But the total energy which is absorbed by the water, because there's a water inside, so how much energy absorbed by the water E is equals to Cm delta T, where C is the specific heat of the water, M is the mass of a water, and delta T is the temperature change. So we just need a ratio of the input energy and the output energy, output over input into 100. That will give us the efficiency of this microwave oven. So if you need the efficiency, you can take in terms of power, you can also take in terms of energy. Efficiency is a useful energy output divided by total energy input times 100. So it will be Cm delta T and it is equals to power into time into 100. C is a specific heat, 4190. Mass of a water is 225, so it will be 0.225 because it should be in kg as this unit is in kg. And temperature change, it's 67.5 minus 15, so it will be 52.5. And it's same 52.5 Kelvin will be there because the temperature change in degree centigrade and Kelvin is same. P is the power, which is 550, and T is the time it takes to heat up. So it is 120 times 100. When we multiply them, we'll get the efficiency of this. It's about 75%. It is efficient. Is it clear? This question? So usually very straightforward questions are there in thermal physics. You don't have to do a lot of like changes in the formula. State a reason why efficiency is less than 100%. That's a journal question they can ask because what will happen? Not all of the energy from a microwave will be absorbed by the water. The flask will also, the container will also absorb some energy. And even if this microwave source is there, it's written 550 watts. So maybe it's not producing all microwaves. Maybe it is producing other radiations as well, like visible light as well. So maybe that might be a reason. So multiple answers are possible. Instead of saying heat loss to surrounding in A levels, it's not look like a appropriate answer. Appropriate in that sense, like you should be more explain your answer that heat loss to a surrounding is a very general thing. Like heat loss to a surrounding in what? Heat loss to a surrounding absorbed by the body of the microwave, heat loss to a surrounding absorbed by the flask. So not only heat loss, that is not the way to write. So you should be specifically what happened to that lost heat, especially when you're answering a question in thermal physics.